Hello, QLR 1000 students. I hope you're doing well. I thought I'd record a very short video going over the homework packet, and that's what I'm going to do. So in week 8, there's a data folder, and I went ahead and uploaded some files that we're going to be going over here. Nebraska beef and scoring NFL. There'll be a second video where I'm going to discuss mapping, where you can utilize these income by county and by state to walk through the data yourself and create some apps in Excel. So with that said, assignment 1.9, you probably saw my announcement. I did go ahead and make this just an assignment that I'm giving you the answers to. Yes, that's true. Uh, like I said, in fairness, I'm also doing this assignment in class for my on-ground students. So I'm just more so hoping that I reinforce three of these learning concepts. So with that said, if we go into the assignment packet here. So the first one, we've been using visualizations, data visualizations and charts to look for trends in data. For example, a scatter plot, you can see if some attributes in different variables play off each other, if they're correlated and have a very strong relationship with each other. So the visual cue of a scatter plot is the first step. There is some statistics behind this. Some of you may have heard of an R squared coefficient of determination. Not a big scary thing. It's just basically a function in Excel, well, a statistical function that when you select two variables will give you a score. It's really that simple. So if you get an R squared of zero point 0.1 or a little higher, it's a weak correlation, right? Shoe size versus your intelligence, probably two variables not closely correlated. What we're looking for is a very strong score. So again, if the scatter dots on a scatter plot are very linear, there's probably a relationship there between the two variables, but this very simple R squared formula, where it's equals RSQ and the Y range and X range are two data attributes, will give you a result. So here it is. If your data was B2 to B10 and A2 to A10 for your two variables, you just type in equals SQ, or you can select your data. I've done this in Excel. And if I go into New York City, so again, we looked at this percent of graduates versus um, either median rent or poverty rate. So I just went in here, and if you can see here, I've highlighted this 0.75. The formula behind that is up here. So I just told Excel equals RSQ, and my monthly rent data is in the cell range B2 to B56, and the percent of college graduates is in the cell range C2 to C56. Hit enter, and it gives me what I think is a fairly strong, according to that chart, uh, range of R squared. So you could say with some pretty good confidence that those two variables are highly correlated. Of course, there's probably the story behind the story. There may be a lurking variable that's causing that relationship. But if you're asked to do this in the business world, beyond just showing them scatter plots, you can actually, in your presentation, give them the R squared so you can have a little more confidence that, say, you're looking at why a store performs pretty well, and you had different customer types like age, income, distance from that travel distance to that store, and all three were highly correlated, you would likely calculate the R score just to confirm that. So diving back into the homework packet, that's the first question. Kiwi Analytics is assessing two very different training programs. And on the surface, these look correlated. There's a linear relationship. At first glance, I would even say that the ones that went through Group B for the training program that Group B went through had a higher success rate. Look at all these scores that are above 1,000 for their performance scores after being trained. So the trick, though, is as you read through these, there's several options. The right one is the strength of the linear relationship between hours of training and evaluation score is actually the same. And perhaps that's a little bit of a trick, but if you look on the graphs, you can see that if we had the raw data for this, and I did look for it, the publisher didn't give it. Both of these, even though the scatter plots look slightly different, they both have an R squared of 0.7, which means that the relationship and the likelihood they are related to each other is exactly the same. So hopefully that reinforces the learning objective of scatter plots and using R squared. So visually they seem very different. I guess I already stated this, but they both have a correlation of 0.0. Question number 2 of 3. So in the next video, I'm going to post about mapping and we're going to dive deeper into geographic information systems, something that's my passion, using GIS and analytics for business and anything from locating where the new Starbucks is to, in a past job, looking at crime statistics. Most likely when you put it on a map, it looks there's some visual trends that you can't necessarily see in Excel or even in a graph. And so what's interesting about this map that was produced in Excel is there's these just the total number of beef. So this larger county up here to the north in Nebraska really stands out in blue. And if that's the story you want to tell, great, you could run with this map. But what's the best choice? So I'll let you read through all these, press pause if you want. But really, answer number 2, it does do a good job indicating the counties containing the most cows in absolute terms. However, there's a tendency for the largest size counties to have the most cattle because of their land area. And this can convey a false differentiation in the density of cows to adjacent counties. So if you're really looking at like how dense is the cattle in these counties, what you would probably want to do is calculate the cows per square mile. And be careful not to be fooled by maps. Often somebody will show you how many Democrats or Republicans voted by county, and it'll be the absolute number versus the density. And so it can be misleading. So if we were to do the map as a density solution, you see that top county, it thins out a bit. The cows per square mile are not as prevalent. But down here, this lower county, sort of the middle to the south, very, very high density. Probably if you drove down a dirt road, every 10 feet you would see a cattle. So just wanted to reinforce that the way you calculate data behind a map can drastically change how that data is being presented. So if we're good to go there, the next one. And final question. So the scoring analysis in the NFL. So originally the assignment was to construct a single chart to allow the audience to make the comparison. So whenever you're given data that has categories such as this, let me zoom in for you a little bit, where you have a team and then a subcategory and then quantitative attribute, usually I would go with a box whisker chart initially. So if you remember back a few weeks when we were looking at real estate data and it was by homes and then by what neighborhood it was in, and then finally the selling price of the house. The box whisker was one graph, a couple clicks of the mouse. You really can tell the story. So let's go insert recommended charts, all charts, box whisker. Okay. Hey, look at this. I've got all these teams with the data. Let's see, how many are there? I've got 320 minus the header row, different teams' annual scores. And in a single chart, I can really see something here. For example, here in 2012, the lowest scoring team in terms of total points and highest score was a very large range. And then the very next year, it seemed to tighten up quite a bit, right? And then it looks like the median across all years of the NFL seasons seems about the same, pretty consistent. And then you can even pick out some of these outliers, right? And so it paints a picture very quickly. So if we were going to describe this, I would say most seasons the scoring distribution of NFL teams is fairly symmetric, very similar, with the mean and median. And then there's been two high scoring outlier teams, Green Bay Packers in 2011 and the Denver Broncos in 2013. And the variability of the total scores from high to low for each year is fluctuates substantially. And so you can read the rest there. So Really, though, the next step would be, what is this really telling you? What's the story behind this? I'm sure maybe some of you know why, these were outlier games or why these different teams performed differently. Maybe there's a different mix of players, trades, who knows? But certainly the next step after analyzing and visualizing the data is to tell the story of the data. So hopefully that helps. Again, all you have to do is upload a document to Canvas, simply acknowledging that you read through the assignment. Or as a bonus, let me know that you actually watched this video. So I appreciate your time, and I look forward to publishing the next video specific to mapping in GIS to finish off Chapter 6.